prepared it using some several past data and some data came from the central bank report. So they given us that generation losses demand for the whole country. Using the load factors, using this information, we are preparing the generation peak and the demand peak. That means the demand at peak time. That our peak time is around 9:30, no 7:30, around 7:30. That we call it as the night peak. So this demand is for that. So using the national power and energy demand forecast, we prepare that, we calculate that demand at peak. So this is for the whole country. Then the next step is to divide them into grid-wise. That is called grid-wise demand forecast. So for the transmission planning, we need that grid-wise demand forecast. As I explained during that our power system so that we have a lot of grid substation. So we need to load forecast for all of this grid substation. So using that previous national power and energy demand forecast, we prepare that grid-wise load forecast. So the input of this grid-wise load forecast is that we have all the past data for all the grid substations. So it is one input and the spot load. Spot load means that the bulk power consumers. Normally, the distribution plan people has that information. Somebody, the company or factory, if they want some bulk electricity, they apply for that. Then the distribution planning people has that information. So we get that information from them. That is spot load. Then the mini hydro power plant connection, because that most of the mini hydro is connected to the distribution network. So from the grid substation we can measure that. So we have to get all the information about the mini hydro power plant, and that is which grid substation they are connecting and which grid feeder, something like that information, and distribution development plan also. The distribution we have 4 distribution regions, all of them prepare the distribution plan, like the same as our transmission plan. So they have some proposals for new grid substations. So when preparing the load forecast, we have to consider that distribution people are our customer. We are the transmission people, that distribution people are our customers, so we have to consider their requirement. So they are our input for the load forecast. The outcome of the load forecast is that then we can use any method. That there are a lot of forecasting methods. That engineer responsible for that can use any of that method as he wish. So when we forecast that this substation loads, that most of the grid substation capacities is exceeding. So we have to give the solution for that. So these are the 3 options, 3 solutions for that all loadings. That one is that cheapest method is the load transfer into the adjacent grid substation. That means that if that consider that both grid substation is exceeding their capacity, we can transfer that load to Moratuwa. Then that is the most economical method. So for that we have to consider that Moratuwa distribution has whether Moratuwa substation has enough capacity, and is there suitable distribution connecting media. We should have some distribution lines connecting both this substation. Otherwise, we can't transfer the loads. And finally, we have to consider that if we transfer that load to the adjacent this substation, whether their voltage criteria and other planning criteria is violating or not. The second method is augmentation of existing grid substation. That means that if one grid substation has 131.5 transformer, then we can develop it as the 2 transformer grid substation. Or if that grid substation has the small capacity transformer like 10 MVA or 16 MVA, we can replace it using the standard size. The standard size of our transformer is 31.5. Or we can use both 10 MVA transformer and the 31 point transformer, but we can't operate them parallel. So the final and most expensive solution is construct of new grid substation. For that, also we have to consider a lot of requirements. That we have to choose the load center. Normally we construct a new grid substation at the load center. So we have to find the place near to the load center. Then we have to consider the transmission line inputs and output. That means that the substation should connect to the power system, that is through the 132 kV line. So possibility of the line connection. Then distribution feeders. From that we should consider it is possible to construct new distribution feeders from that new grid to the load center. So there are several requirements to consider. So this is our typical daily load. So I am doing this because I need this information later. Normally we have this is our night bill around 7:30, and normally here is our day bill. It is around 11 a.m. And around here it is lightly loaded condition. 3 types of load forecast. They are system this substation demand forecast at system peak. System peak means the night peak around 7:30 p.m. and this substation peak demand forecast. That means that most of the grid substation has the night peak demand, but around Colombo and the Biagama, grid substation had the daytime peak demand. So combining these two, we prepare that peak demand forecast. It is just to figure out that capacity requirement and the day peak demand. Demand forecast and day peak. This is our demand forecast at time. And that other point is that when we prepare this load forecast, required load forecast, the summation of the required load forecast should equal to that demand at national power and energy demand forecast. Next input is that generation expansion plan. That generation, long-term generation expansion plan is